Okay, everybody's favorite. Gotta love word problems. So we're going to look at some quadratic word problems today, and you can see how quadratic equations are really applicable to some things that you'll see in life. So this first example talks about a carnival game where you strike a lever and it forces a weight up a tube, and it's asking you if the weight reaches 20 feet to ring the bell. Um, and it gives you the equation there, negative 16t squared plus 32t plus 3. The initial velocity is 32 feet per second. Notice that initial velocity is plugged into the equation already. It's plugged in right here. So this is actually really useless information right here. It's already plugged in, so you can kind of cross that out. It asks you to graph the equation and then answer the questions. So we are going to do this by hand today, not with our graphing calculators. We will learn to do that a different day. But for right now, we want to learn to do this by hand. So it's been a while since we've done this. We did this the very first day of the chapter. So I know it's been a while and we need to review it a little bit. So here we go. The axis of symmetry, remember, is negative b over 2a. So in this particular problem, your a is negative 16 and your b is 32. So we will plug that in now and we will do the opposite of b. So the opposite of b is negative 32 over 2a. So that's 2 times negative 16. So I get negative 32 over negative 32, which of course reduces to negative 1. Okay, so that gives me my axis of symmetry. So when I go graph here, I could graph my axis of symmetry at 1. I wrote negative 1, sorry, positive 1. Okay, my axis of symmetry is at 1, and so this is where my handy dandy little axis of symmetry will go if you want to put that in. I also know that my vertex is going to be somewhere along that line. So to find my vertex, what I need to do is I need to take this 1 that I got right here, and I need to plug it back into the equation. Okay, so I'm going to go negative 16 times 1 squared plus 32 times 1 plus 3, and I will figure out what I get. So on this one, remember you guys that you need to square the 1 first and then multiply it by negative 16 instead of taking negative 16 times 1 and squaring it. So when you do this, you will get negative 16 plus 32 plus 3, which gives you 19. Okay, so this is the y coordinate of your vertex. Your vertex then is at 1 and 19. Okay, so I want you to pay attention to the scale on the graph too. I want you to notice that they go by twos. So this is really 2, 4, 6, 8, 10, 12, 14, 16, 18, 19 is going to be right here. So your vertex is at 1, 19, and it's hard to do this small enough up here, but that's how that should look. Okay. So there's your vertex. Then what we're going to do is we're going to make ourselves a little table. We're going to put the vertex in the middle of it. So the vertex is going to go right here. And then I want you to go one x value up. So one x value past 1 is 2, and one more is 3. And then we go x values down. So negative 1 and 0. Okay. Then you're going to plug these numbers in, and you're going to get yourself an answer here. And I should flip those two around. Sorry, 0 and negative 1 is what I should do. Okay. All right, here we go. We are going to figure this out. Again, we're going to plug every single number into the equation. So on this one, I'm going to go negative 16 times negative 1 squared plus 32 times negative 1 plus 3. Okay, you can stick that into your calculator, but you need to simplify that. That's what you need to do. When you do that, you should get negative 45, and you can go ahead and check your answers. Okay, and then for 0, you'll go negative 16 times 0 squared plus 32 times 0 plus 3. Plug it in, get an answer. You should get 3. Keep going. We've already got 1 and 19. When I do 2, I'll do negative 16 times 2 squared plus 32 times 2 plus 3. Okay, plug it in, check it, and you'll get 3. And then when you plug the 3 in, you'll get 45 again. So you should notice some symmetry about this, which we do here. And so now I'm going to plot those points. So first I'm going to plot the point 0, 3, which is right here. And then I will plot the point -1, -45, which is right here. And I'll keep plotting the other points as well. Okay, so when you plot them, it should look something like this. Okay, it's kind of a crooked parabola, but we get the gist, and I really should probably fix that right side a little bit and make that a little nicer and cleaner. All right, that looks a little bit better anyway. Okay, so there's the first step. We made our table, we graphed it, and now we're going to answer some questions about this parabola. Okay, so the first question is, what's the maximum height of the object? So the maximum height we can see right up here. This is where the maximum height is. The height is the y value. So you want the maximum height, the maximum y value, but I also want you to tell me where it is. So that happens to be the vertex. The highest it gets is 19 feet above the ground. And it's when your x value is 1. So this is the point 119 right there. The y value gives you your height. The x value tells you when it happens at, because along the x-axis is time and along the y-axis is height. And we probably should have labeled that from the beginning. Okay, so I want you to write me a little sentence that says something like this. The max height is 19, and we're in feet here, 19 feet at 1 second. Okay. In the next question, I've already answered it now. At what time does the object reach the maximum height? At 1 second. But I want you to kind of think of that as a package deal. You can't have a maximum height without knowing what time it happens at, because it will make a difference later on in some things that you do in math. Okay, so pay attention to what time that happens at. The next question is, what height did the object get released from? So here we go. When we look at this parabola, remember along the x-axis is time. And you aren't going to count negative amount of time when you do this. So quite honestly, this piece of the parabola, until I get to where the point where time is 0, means nothing. I don't even need it. It doesn't matter. It means nothing. I can't have negative time. This is the point where it gets released at, right here. Obviously, your x value is 0 at that point, and remember your y value is 3. Okay, again, x is time, y is height. So it gets released at 3 feet. How can I tell? That's when the time is 0. Okay. How long does the object take to return to its initial position? So if I go back up here, this point right here is where it returns to initial position. Okay, that's the key point. At that coordinate, we know that the coordinate there is x is 2 and y is 3. Again, x is time, height is y. Okay, so it says how long does it take the object to return to its initial position? And that would be, it returns to its initial position of 3 feet in height at 2 seconds. Okay, and how can you tell I'm on our say C graph? Because we labeled it up above. Okay, if the object were to keep traveling at approximately, and we're going to estimate this, what time would it hit the ground? Okay, here's where it will hit the ground. It will hit the ground right here. Okay, that's when it's going to hit the ground. It does not have to be, or it does not look like it's at an even coordinate, but I know it hits the ground there. And the only thing I know about that coordinate is I don't know what my x value is. That's a big old question mark. But I do know that my y value when it hits the ground means my height has to be 0. So my y value on that spot is 0. So now what you're going to do is you're going to go down here, and what you need to do is you need to think about this equation, okay? And remember that the equation, um, if we wanted to get more specific, we could solve it, but we're not going to. The height is 0. What I know is that it happens somewhere past 2 seconds and before 3 seconds. We're just going to estimate here. I know that it's somewhere between 2 and 3 seconds. That's all we're going to do. I could teach you to do it another way, which we will do on a different problem, okay? But for right now, all I know is that it's somewhere between 2 and 3 seconds. I could use the quadratic formula and solve that. I am not going to do that right now. The question is, will the player win the prize? And remember that the maximum height it hits is 19 feet up here. And in order to win the prize, they have to get to 20 feet. And so, no, they will not win the prize. Okay, nope, they're only ever going to reach 19 feet. They'll never get to 20 according to this equation. Okay, so there we go. Here's another one. It's talking about an object being fired straight from the top of a 200-foot building. I want you to notice that if you look at the parabola, it's being fired from a 200-foot building. This is where it's being fired from. Again, anything to the left of the y-axis, this part over here, really means nothing. It doesn't matter. Unfortunately, the program that I use to create this, you can't delete that part of it. What a bummer. Anyway, so I've got my parabola there. Its initial velocity is 80 feet per second, which is already plugged into the equation for you, so you don't need to do anything with that. It's just extra information. The height of the object is given by that equation there. Okay, so here we go. Find the maximum height reached by the object and the time that it is reached at. Okay, so the height of the maximum objects. First of all, I have to use the axis of symmetry equation. So to find the axis of symmetry, again, I will do negative b over 2a. Right here, your a is negative 16 and your b is 80. Okay, so when I plug this into the equation, I will do the opposite of b. So the opposite of 80 is negative 80 over 2a is 2 times negative 16. So I have negative 80 over negative 32, and that reduces to 2.5. Okay, and then of course I will plug that in. So I'll take that 2.5 and I'll plug it in, and I will do negative 16 times 2.5 squared plus 80 times 2.5 plus 200. And when you simplify that, and again, you guys, remember you need to square the 2.5 first and then multiply it by negative 16, just so you know. When you do that, you get 300. Okay, that means that my vertex is at 300, sorry, not 300, 2.5 first, 2.5, 300. Okay, and you can see that point right here. Here's your vertex. You can see the coordinate is at 2.5 and 300. Okay, that is the highest that it is going to reach. So again, I want you to write a sentence that says something like this. The max height is 300 feet at 2.5 seconds. Okay, something like that is what I want you to write for that. This one says find the y-intercept, and what does it mean in this situation? The y-intercept means it's where it crosses the y-axis. So right here is the y-intercept. Okay, what does it mean? It's where the object hits the ground. And obviously at the ground, the height is 0. So it's where the object's height is also 0. Okay, and then part C, when does the object return to the height it was released at? Remember that it was released from 200 feet. So the object starts right here, it goes up, it comes back down. Here's the point where it gets back to the height it was released at, which we can see happens at 5 seconds. Okay. If we didn't know that, if we couldn't see it exactly from the graph, what we could do is we could say, all right, when is the height 200 again? So I could do 200 equals negative 16t squared plus 80t plus 200. And then I could solve it by factoring if I wanted to. I don't need to do that in this case, but I could. Okay, I could solve it by factoring. I could solve it by doing the quadratic. All right, and the very last one. This is another similar problem, so I want you to just get some good ideas of what's happening here. Here, a player is hitting a ball at a 45-degree angle. Its initial velocity is 80 feet per second. The equation is given for you. It tells you the path of the ball, and again, we need to figure out what the maximum height is when the ball, yeah, what the maximum height is and when it reaches it, okay? So here we go. First of all, we need to find the axis of symmetry, okay? So we're going to do negative b over 2a. Negative b over 2a. All right, so here's the deal. Again, I will start with negative b over 2a. Okay, here is your a. Here is your b. So when I do negative b over 2a, I will have the opposite of 1. So I will have negative 1 over negative 2 times negative 0.005, which gives me negative 1 over negative 0.01, which gives me 100. Okay, that's the x value. And in this equation, the x value stands for the horizontal distance that the ball travels. I want to know the height, so I have to plug that in. And so when I plug that into my equation, I will plug it in like this. And I will go negative 0.005 times 100 squared plus 100 plus 3. Okay, and when you simplify all of that, you should get 53 feet. That is the y coordinate or the h in your problem here. So the maximum height it reaches is 53 feet, and then the horizontal distance it took to get there was 100 feet, the horizontal distance that it traveled. Okay. Then the next question says an outfielder catches the ball 3 feet above the ground. 3 feet above the ground basically means that your height or your h is 3. And the question is, how far has the ball traveled? Again, the horizontal distance that it traveled. How far has the ball traveled? That's your x. And that's what I need to find in this case. Okay. So what I will do is I will plug this in and I will say 3 equals, and then I'm going to plug it into my equation, negative 0.005 x squared plus x plus 3. Notice I plug a 3 right here because this is where the height is. The equation goes h equals, okay? So the height is 3. Now I'm going to solve by subtracting 3. And then I get this, negative 0.005 x squared plus x. And then I have it equal to 0. Okay, those cancel, so I have it equal to 0. Now what you can do is you can factor out an x. So if I factor out an x, I will have negative 0.005. Okay, and then plus 1. Then I'm going to set each part equal to 0. So I'm going to take the part that's in front right here, and I will set it equal to 0. And then I will take this equation just like you always do when you factor and set it equal to 0. Here, obviously, I get x equals 0. Um, here, if I subtract 1, I'll get negative 0.005x equals negative 1. Divide by negative 0.005. And when you do that, you're going to get x equals 200. Um, so basically what this is telling you is that it's 3 feet above the ground. The height is 3 feet above the ground when the time is 0. So it's 3 feet above the ground, first of all, when he releases it. And second of all, it's 3 feet above the ground at 200, and I should label this feet. Okay? And then, if the outfielder misses the ball, how far will the ball travel before it reaches the ground? So at the ground, the height is 0. So what this is asking you to do is take 0 equals that handy dandy lovely little equation, which is this. Okay. It is set equal to 0, and you can try to factor that if you want, but the easiest thing to do would be to do the quadratic formula. And remember that the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. I could sing you the song, but I won't get it in your head. So that's how that's going to go. Okay? Your A is here, your B is here, and by the way, your A is negative 0.005, your B is 1, and your C is 3. Okay, when you plug this into the quadratic formula, then you will have the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2A. When you simplify all that lovely stuff inside the radical, you have negative 1 plus or minus the square root of 1.06 all over negative 0.01. Okay, and then you're going to type this once into your calculator. We're going to estimate as negative 1 plus the square root of 1.06 divided by negative 0.01. Make sure you press equals after you did negative 1 plus the square root of 1.06 equals divided by negative 0.06. When you do that, you'll get negative 2.96 feet. Well, you can't travel a negative horizontal distance, so this answer actually makes no sense in the problem. And then you'll do it again with negative 1 minus the square root of 106 over negative 0.06. And when you plug that into your calculator and you get an answer, you should get 202.96 feet. So it's going to travel 202.96 feet horizontally before it hits the ground.